This video is for after your 6.1 through 6.2 quiz, and it will cover section 6.3, so trigonometric functions of angles. So far we've done trigonometric functions on the unit circle. We just did trig functions with triangles, but trig functions are not limited to acute angles. When we work with triangles, all of the angles are acute. However, we can take trig functions, we can evaluate them at obtuse angles. So to evaluate trig functions at obtuse angles, we will use triangles on the coordinate plane. Okay, so we just need to make sure that we've got all of our reference points correct. So on the coordinate plane, we always start with the x-axis as our starting position, 0 degrees, and then we rotate through. This green ray is our terminal point, and we make a triangle out of this. Okay, so then we have an x and a y for our x coordinate point, our y coordinate point, and then we call this r. In the unit circle, r was 1, but r does not have to be 1. It can be anything. R, we know that r squared has to equal x squared plus y squared. So r is going to be the square root of x squared plus y squared. That's how we're going to define our r. So that's our radius. And it is good to note that r is always positive. Okay. So on the coordinate plane, when we make triangles, we are going to have our definitions of all of our trig functions are going to be very similar. So sine of theta here would be still your opposite over adjacent, but here opposite is your y coordinate, adjacent, sorry, not opposite over adjacent, opposite over hypotenuse, pardon me. It's going to be y over r. Cosine of theta is then going to be x over r. That's adjacent over hypotenuse. Tangent is opposite over adjacent, so y over x. Cosecant is going to be 1 over sine, so that fraction is just going to flip. Same thing for secant, and then for cotangent. Okay, so the way these are all defined is very similar to with regular right triangles. We are just defining them on a coordinate plane now, whereas for 6.2, we were not on a coordinate plane. So we're going to look at how you can use a coordinate plane if you're given sine. So here I'm given sine. Let's figure out if theta lies in the first quadrant, what is cosine of theta? Okay, so here we're going to have our little coordinate plane. And I know that my theta is square root of 2 over 3. Okay. So sine theta is square root of 2 over 3. So that means that square root of 2 is my y value, and 3 is my radius value. Okay, and I need to figure out what x is. So I can use my new definitions, which are really just the old ones, just on the coordinate plane. I'm going to use the fact that r equals square root of x squared plus y squared. So I have 3 has to equal the square root of x squared plus y squared is going to be 2. I can square both sides, subtract 2, and then I'm going to get x equals plus or minus square root of 7. So we have to choose if x is going to be positive or negative. So it's the same thing as happened on the unit circle. Because we're in quadrant 1, x is going to equal positive square root of 7. So that means cosine of theta is then going to be, I'll label this as square root of 7, it's going to be square root of 7 over 3. Okay. So this angle that we just did was on the coordinate plane, however, it was not obtuse. So when we have obtuse angles, what we have to do is we actually have to use what's called a reference angle. So a reference angle is an acute angle formed by the terminal side of an angle and the x-axis. So let's see what this would look like. So for instance, let's say we have an angle of 100 degrees. What that's going to look like is we'd go to 90 and then we'd go 10 more degrees. So I'm going to say, that might be a bit thin. We're going to say that this is 100 degrees. The reference angle, so this definition says it's the acute angle formed by the terminal side of an angle and the x-axis. So you always form it by dropping down to the x-axis. So it is this angle, and we denote it with theta with a bar over it. So here my reference angle is equal to, it would be 80 degrees, 180 minus 100. Okay, let's look at if I had an angle that ended up in the third quadrant. So let's do a 240 degree angle. So that would end us up in the third quadrant, about there. That's 240 degrees. So then my reference angle would equal 240 minus 180. It would be 60 degrees. I can have reference angles even with angles that are above 360 degrees. So let's draw a 380 degree angle. For 380 degrees, I'd go all the way around, and then I'd go 20 more. So this could be a 380 degree angle. The reference angle would then be 20 degrees. So these reference angles, always consider them to be positive. Even if, for our last one, let's draw a negative angle, a negative obtuse angle. Let's do negative 150 degrees. So negative 150 degrees is going to be right about there. Negative 150 degrees. Reference angle, it's going to be exactly 30 degrees. Take 30 more degrees to get to the negative 180. Okay, so when we have these obtuse angles, what we're going to do is we're going to be making triangles with these reference angles. And then we can evaluate our trig functions at the reference angles. Okay, so here, 5 sine of theta equals 3 over 7, and theta lies in quadrant 2. We want to find the values of cosine of theta and tangent of theta. So let's draw a little picture. Straight lines. Okay, so we have 3 over 7, and we're in quadrant 2. So it's sine. So this is theta, but I'm going to use my reference angle here. Okay, so sine is opposite over hypotenuse, so it's 3 and 7 here. We need to figure out what our x value is. So here you can use just Pythagorean theorem. Whoopsies, that's all that the r value is. That's how you find it. Pythagorean theorem. So now that x squared plus 3 squared has to equal 7 squared. So x squared plus 9 has to equal 49. X squared needs to equal 40. That means x is going to end up being, it's going to be plus or minus square root of 40. So it's going to be 2 square root of 10. So we have to determine, is it going to be positive or is it going to be negative? Since we are in quadrant 2, x is going to actually be negative. So this is negative 2 square root of 10. So now we can evaluate cosine of theta, which will be negative 2 square root of 10 all over 7. And then tangent of theta. It's going to be 3 over negative 2 square root of 10. You do need to multiply by square root of 10 on the top and the bottom though. You will get 20. That's still negative. Okay, So the main thing here is to not forget that negative for the x value. All right, so the last thing for today is we're going to talk about how we can use our special right triangles to evaluate trigonometric functions at any obtuse angle, as long as the reference angle is one of those special angles, the 30 degree, 45 degree, or 60 degree. So we cannot find exact values for every single angle or every single obtuse angle, but we can find exact values for them if their reference angle is one of these three. So let's look at sine of 120. So 120 degrees, if we draw that on the coordinate plane, it's going to end up being, that is 30 more than 90. So up there, if we make a triangle, this angle will be 60 degrees. I'm going to draw that bigger. $60-degree angle. So with our special right triangles, again, since we're evaluating the sine function, all that matters are the ratios. So we don't need to include the x's, we just need to include 1, 2 for the hypotenuse, and square root of 3. Remember, however, that x is going to be negative here, so it's going to be -1. All right, sine then is going to be opposite over hypotenuse, so it's going to be square root of 3 over 2. Our next example is sine of 4 pi over 3. So 4 pi over 3, if we draw that, that ends up in the third quadrant down here. The reference angle, we'll just go ahead and do it in degrees, would be 60 degrees again. You can fill in the side lengths with our special right triangles. Hypotenuse is 2. The short leg would be -1. Long leg would be negative square root of 3. Sine then is the opposite over hypotenuse, so it's going to be negative square root of 3 over 2. All right, cosine of 150 degrees. So 150 degrees, if we draw that on the coordinate plane, it's going to have us end up somewhere around here. It's going to be a 30-degree reference angle. So we have our special right triangles again, remembering our negatives for negative x in the second quadrant. So cosine here is going to be adjacent over hypotenuse. So negative square root of 3 over 2. Okay. So we're flip-flopping back and forth between degrees and radians. So here, for 11 pi over 6, that angle looks like about here. Maybe not quite so narrow. And that gives us a 30-degree angle for the reference angle. Reference angle is 30 degrees. Radius is always positive, is 2. Long leg is going to be square root of 3. Short leg is going to be -1. Y values are negative here. And cosine is adjacent, square root of 3 over hypotenuse, which is 2. Back to degrees. 225. So that's going to spit us out in the third quadrant. Take a moment to think about what that reference angle would be. It's going to be 45 degrees. Hypotenuse is going to be square root of 2. Both legs for this one will be negative. Third quadrant is negative x's and negative y's. So cosine will be -1 over square root of 2 or negative square root of 2 over 2. If you are good at relating these to the unit circle, you are welcome to do that as a way to check this. Move on to tangent of 300. So 300, think about which quadrant that's going to end up in. It's going to end up in the 4th quadrant. And the reference angle there, we make a triangle with the x-axis. This is 300 degrees. We would have 60 more to go. So the reference angle is 60. So this will be square root of 3, except it will be negative 1 and 2. So tangent would be negative square root of 3 over 1, so negative square root of 3. All right, moving on, cotangent, we're getting a little more complicated with cotangent. So cotangent, so 2 pi over 3, thinking about the unit circle now, 2 pi over 3, we're going to end up in the 2nd quadrant. So the key thing here is remember you do not want to draw that triangle. Reference angles are all about making angles with the x-axis. Make a triangle with the x-axis. So here our reference angle would be 60 degrees. This would be -1, 2, square root of 3. Cotangent is going to be, that's x over y, so it'll be -1 over square root of 3, which will end up being negative square root of 3 over 3. All right, now we've got an angle that's above 360 degrees. So it will go all the way around, and then it will go from 360 to 405. That's 45 more degrees. That's such a wavy line. Okay, 45 degrees. So this will be square root of 2, 1, and 1. So cosecant is hypotenuse over y, or I should say r over y. So it's going to be square root of 2 over 1. It's just square root of 2. All right, and then our last one for this, we've got a negative angle. So we are going to do -210. So -180 would be to the other side of the x-axis, and then we are going to go 30 more degrees. So that's 30. Oh. Pen is not wanting to cooperate today. 30. There we go. So this will be 1, negative square root of 3, and 2. So cosecant, again, is going to be r over y. So it's going to be 2 over 1, or just 2. Okay. So the last thing is, if the terminal side of an angle lies on the x-axis or the y-axis, there is no reference angle. We cannot make a triangle out of it. So in these cases, you just need to think about the unit circle. So just think about a coordinate system, coordinate plane. Let's see if it will recognize a circle. Lovely. Okay. So the unit circle, we have 0 degrees, 90 degrees, 180, and 270. So think about the coordinates there. So sine of pi over 2 is the same thing as sine of 90, and that's just going to be 1. Cosine of 180 is the same thing as cosine of pi, so it's going to be -1. And then tangent of 270, so tangent is still y over x. So in this case, y would be -1, x would be 0, so this is undefined. Okay. So for these angles, for the ones that are multiples of 90 degrees, you just think about the unit circle. All right, so you guys have homework on Delta Math. In this homework, I'm not going to require you to show work.